received Vidyasagar Memorial Research Award from Vidyasagar University for his excellent contribution to research in 2023. Basically, Professor Paul has successfully guided till now 46 research scholars to guide PhD degree and has published more than 440 articles in international and national journals. His specializations include algorithmic and fuzzy graph theory, fuzzy matrix, genetic algorithms, and parallel algorithms, subcomputing, topological index. So, Professor Tom has immense knowledge in different disciplines about graph theory. He also completed 4 research projects funded by UGC and BST. He is the editor-in-chief, Journal of Physical Science, Annals of Pure and Applied Mathematics. He is the associate editor of International Journal of Computational Intelligence System. That is actually SCI in the journal. Associate editor of Journal of Applied Mathematics and Computing, SCI Index, and member of the editorial boards of many journals that is not mentioned. So you are very lucky to get our this eminent mathematicians and immense knowledge holder person, Professor Madhumangal. I request her to start your deliberations about fundamentals of quantum theory. So I think all participants will be very much benefited for his lectures. So please. So good morning once again, and thanks Dr. Mondo for introducing me. So now I will discuss regarding the fundamentals of algebra theory. So basically see that we know graph theory. The students are highly familiar with the graph theory, the conventional graph theory. But for the beginners, some of them are forget what is graph theory, and also some are the beginners who is in this area. So just before going to the graph theory, just try to introduce what is graph. So graph basically is an algebraic structure. Basically algebra, like a group theory, league theory, and so on. But it contains two sets. One is a set of vertices, that one is denoted by V, and another is a set of edges, that one is denoted by D. So the sets, you know what means by sets. So E and D are two sets. It may be finite or infinite. If any one of these two sets is infinite, then the graph is called the infinite graph. Otherwise, if the both sets D and E are got finite, the graph is called the finite. So most of the people are working on the finite graphs. So here also I discuss regarding the finite graph, finite Fuzzy graph basically. So what is the graph? The set of vertices here, any graph can be represented in a diagrammatic representation. So this is the one of the major advantages of graph theory. It may be represented as algebraic form. It may be represented in terms of diagram. It may represent in a internal computer with the help of some mathematical tools, like you see on matrix or conventional matrix, or it can also be represented with the help of your linear list, that one used by the computer scientists. So there are three types of representation of the graph theory. One is algebraic, another is diagrammatic, another computer's representation. So you see that the vertices are denoted by the diagram with the big circle. It may be small circle, It may be solid circle. There is no limited your notations, but generally we are taking the vertices by side. Okay. And the line, straight line or path line are denoted or represents the edges. That means the connection between the vertices. This means the connection between the vertices. So we have ABCD etc. of the vertices and ABCD etc. of the edges. So this is a graph in terms of your uh, tape sets. So, what is the meaning of the vertices? What does it represent the vertices? So, the vertices may be your a collection of cities of a country, or it may be a collection of cities of a state, or collection of cities even in a district. So, it may be cities, collection of cities. These are the object basically. Collection of colleges in a particular geographical region for a particular university or particular state, etc. Collection of universities, collection of colleges as well as universities, including you may include also the schools, people in Facebook, all the people who are who have accounts in Facebook, so they are they may be the nodes of the party. Now, people in WhatsApp, no, we are using WhatsApp, Facebook, these things, these social networks. So every people, every group of people in WhatsApp may be considered as a node or vertex of a graph. And variables in computer program. We are writing the computer program, so a lot of variables are there, or we are using a lot of variables. So a variable can be considered as a node. So many other applications or many other your real life situation can be represented with their programs. Similarly, what are the edges? So connecting the cities by roads, it may be the normal roads, or it may be the cities may be connected through a railway connection. The cities may be connected by flight. A lot of things are there. Similarly, roads are the edges, considered as edges connecting the cities. Faculty interaction. Faculty interaction, faculties means the faculty of colleges or universities or schools. The interaction between or relationship between the faculties and the interaction will be considered as a edge of the graph. Interaction between peoples. A lot of people are there in the social network or in other networks also, LinkedIn, etc. So interaction between the people may be considered as an edge of the graph. Simultaneous activeness of program variables. Here we have mentioned the variables of a program may be considered as the vertices of the graph. Similarly, if two vertices, two variables are simultaneously active during the execution of the program, then we consider an edge between the vertices. Okay. So this is another thing. So for every program, we can in any language, for every program, we can construct a graph. So that one is an interesting thing. So these are the some your common application of graph theory. It may be the vertices or edges may be the certain or uncertain. So apart from the edges and vertices, there is another parameter associated to there may be another parameter associated to the vertices or edges. That parameter is called the weights associated to the vertices or associated to the edges. So weights may be road distance. So distance between one place to another place, that distance may be represented as a weight of that edge. And your
PowerPoint.
travel times, travel times from one place to another place, that also considered as the weight of the edge. Frequency of interaction. Frequency of interaction between two persons in a social network may be considered the weight of the edges. Timings of activeness. We consider the variance in a program. That means the duration of the activeness of the variables that also represented as your weights of the edges. So these are the very simple applications of graph theory. This graph may be the Gibbs graph, this conventional graph, maybe the fuzzy graphs. So there is interesting issues in fuzzy graph theory. So see that the graph theory is a subject. That subject is studies in two different directions. So this is a rare subject we can see, or rare topics of mathematics we can see. So it can be your studies in completely two different directions. One is the algebraic graph theory. So in algebraic graph theory, people are trying to find out the properties of graph. Our BJ student, those who have already studied the graph theory, they knows We are studying different properties of graph theory, and also we are studying the upper bound of some parameter or exact bound of some parameter. So these are the algebraic study of the graph. And on the other hand, algorithmic graph theory means we have designed some algorithm, no, like your algorithm to solve the LPP sequence algorithm. Similarly, you can design the algorithm to find the parameters, exact values of the parameters of a graph using algorithm. So the computer scientists, generally the computer scientists are working on algorithmic graph theory. To studies in this area needs your little bit knowledge on data structure and the computer organization of memory like that. So this is basically this is a subject of computer scientist, but a mathematician can also work on this particular area about the graph theory. And since again see that these two areas, algebraic graph theory as well as your algebraic as well as algorithmic graph theory can be done on grids or conventional. Similarly, we can also investigate these two areas for the first. So during this last 50 years, a lot of people are worked on fuzzy graph theory for the algebraic sense as well as your algorithmic sense. So these are the entire direction of the investigation of the graph theory in both the grids graph and as well as your fuzzy graphs. Now, question is, what is the importance or what is the need of fuzzy graph? No, graph is here. That one is invented in 1737 by Euler. Someone who already mentioned to solve the Anish-Bayes problem. That was the long-standing unsolved problem that the Euler in 1737 he solved the problem with negative answer. So now the question is why fuzzy graph? So see that the structurally or pictorially or algebraically, apparently both the graphs are same. There is no major differences. But if the vertices and edges are uncertain, that means the vertex or edges sometimes appears in the total picture, sometimes not appear, sometimes appears for a very limited amount of time like that. So if the vertices and edges are not certain for the appearance or for the computational side, then the fuzzy graph theory is required to analyze or to represent such kind of situation. Okay. That means in the fuzzy graph theory, there is a number associated to each edge as well as its vertex. That one is called the degree of appearance or degree of recursive value that represents the degree of uncertainty. Okay. If the degree of uncertainty is equal to 1, then we say that vertex or edge is the certain. So this is the reason. If the uncertainty is here, then we consider fuzzy. There is no uncertainty, there is no need of fuzzy. This is the clear thing. So this is a diagram. Diagram means that it is the my research group in the center position. I am in the center position and other researchers are in the other position. So see that each researcher is considered as a vertex of the entire graph. That one represented within a circle. And see that the connection is interaction between the researcher, between any two researchers. That one, if there is interaction, so we have drawn an edge. If there is no interaction, so there is no edges. And also see that there are some numbers associated to the nodes and associated to the edges. So what is the meaning of that thing? That means see that the some researcher are continuously doing research after his or her PhD degree, and some of them are totally stopped, and some of them they are working little bit your areas, basically, what very small time as training to work for the research purposes. Okay, so depends on the activeness in research. So depends on the activeness on the research. We have scaled it between the 0 and 1 unit. So that number are associated with the each members. Okay, so that one is called the degree of activeness in research. You can say the degree of activeness, and certain number are associated with the ages. That means that represents the degree of interaction between the two researchers. Okay. So it may be highly interacted, there is no interaction at all. Only limited time they are communicating to discuss the research problem or the other things. So based on the degree, based on the interaction, we have your calculated the degree of interaction. That one is called the degree of membership between the interaction, and that one is called the degree of age membership. So the interstructure is called the fuzzy graph. So we have mentioned the number replaces the degree of friendship. Yes, if you consider all the members in this diagram are friends, so degree of your interaction replaces the degree of friendship. Okay. So this is basically a fuzzy graph, and we can say this is the network of fuzzy friendship or network of resources. Okay, so we can model any small group of people or a very large group of people as a fuzzy graph. Similarly, we see that the your world largest network. I don't know actually what is this, but it may be Facebook, it may be WhatsApp, or it may be another kind of social networks. Okay. So these are the very big networks, but a lot of huge number of some crores the vertices of this kind of networks. Now, application of fuzzy graph as well as graph. So, lot of applications are there of the graph theory, but here we are mentioning it in few. The communication network can be represented with the help of graph theory as well as by the fuzzy graph theory. That is internet, mobile, these are the communication network. Similarly, the social network, Facebook, your WhatsApp, these are the well-known social network, but research it is not the social network. This is a network for the research. Similarly, Twitter is a social network. LinkedIn is another network which is useful for the student who are seeking the jobs or the industry people who are giving their jobs. So LinkedIn is a very useful network for student as well as the employer. Employer means who are giving jobs. Similarly, city planning means your road signal, in the junction, physical road, the lighting is there, no, red light, green light are there. So that can be minimized with the help of graph coloring problem. So graph theory is used to city planning. Transportation is the transportation from the goods from one place to another place. DNA analysis, no, gene analysis basically there. Graph theory is used. A lot of applications are there. Now I coming to the definition of fuzzy graph. What is the actual definition of fuzzy graph? Someone go before my completion. 20, 20. So for 5 minutes there. So see that one. Now I try to define the fuzzy graph theory. So I have already mentioned the graph theory is invented by Joseph in the year 1975. So for this reason we are celebrating 50 years of fuzzy graph theory. You see that in a graph, in a conventional graph, you see that a graph can be represented with the help of set of vertices and set of equals. No, there are two sets. But in fuzzy graph theory, there are three things. One is G that represents set of vertices and two functions, sigma and mu are two functions. That one is the mathematical functions. So what is this? Sigma represents the degree of membership of vertices and mu represents the degree of membership of the edges. Okay. So two what is it? Two membership function. Sigma and mu both are mapping from D. Sigma is mapping from D to unit integral 01. So unit integral 01 represents the degree of membership here. And D is the set of vertices. And see that mu as a mapping from D cross D. D cross D is any Cartesian product, no, between B and B, any element of the Cartesian product B cross B represent an H. Okay. So mapping from D cross B to unit integral 0. If the membership value of a vertex is 0 or membership value of an edge is 0, then we can say that vertex or that edge is not present in the graph. But if if the values of the membership values of the vertices or edges is more than 0, then we assume that that particular vertex or edges are present in the graph. So see that these are the your definition of the function sigma and mu, and there is a restriction mu of xy less than equal to minimum of sigma is comma sigma. So what is this? This is a restriction on the functions. So mu and mu x represents the membership value of the vertex x. Mu y represents the membership value of the vertex y. Okay. So minimum of these two values is the upper bound of the membership value of the edge joining x and y. That means x and y is an edge, and two edge vertices are x and y. Their membership value, the edge membership value is less than their corresponding membership value of the participants. Okay, so this is a restriction. This is a restriction, and nowadays, nowadays, yes, last 5 years, that restriction is removed, and you are incorporate another type of restriction, or if you remove any restriction, then that kind of algebra is called the generalized algebra. But generalized fuzzy graph does not satisfy all properties of the fuzzy graph. That there is a fuzzy graph without any restriction, that one is generalized fuzzy graph, but generalized fuzzy graph does not fulfill all the conditions or all the properties of the fuzzy graph. So this is a conventional representation of fuzzy graph. So you see that vertices A, B, C are there, and the number associated with the A, B, C represents the degree of membership value. And there are three edges that membership values are 0.45, 0.6, 0.5. So here we have tried to represent the ages based on their membership values. So see that if the membership value is high, then the line joining the vertices is your little bit dense. And the membership value of the age A, B, see that the membership value is 0.45, very less. So the line is dotted with more gap. So this is one concept to represent the ages of the budget. But this is very complicated because membership value is a continuous number between the unit interval 0. So it is very difficult to represent the ages, the dots, or the gap between the dots as per the membership value. So we are generally represent the budget graph as per conventionally by drawing the solid lines, and we are trying to write the membership value is by each. So type of fuzzy graphs. So different type of fuzzy graphs are appears in the literature. In 2002, M. Ru has published one paper and he classified the type of fuzzy graphs. So type 1 represents the creep, vertex state, and fuzzies. That means all the vertices are certain. There is no uncertainty, but the edges are uncertain. Creeps, vertices, and edges with fuzzy connectivity. Connectivities are uncertain. There are some examples are there. Fuzzy vertex set and creeps its. So to define this type of fuzzy graph, but as per definition, this type of fuzzy graph does not exist. Okay. This is not mathematically correct. Theoretically, we can say the vertices are uncertain and edges are certain. It is not possible. Another type of fuzzy graphs is Creep's graph with fuzzy weights. This the vertices, edges are uncertain, but the weights, that means travel time, distance, all these things are certain. So this is another fuzzy graph. And fuzzy set of Creep's graph means certain Creep's graphs are there, and the composition, different type of compositions are there. The composition of fuzzy composition. So using that operation, we can also define another type of fuzzy graph, that one is denoted by type fuzzy. So these are the main types of fuzzy graphs. How many types it is? How many types it is? 10. So now we can, okay, I am skipping this one, paths, etc. So here, because the lack of time, we will do another one. Variants of fuzzy. This is another important issue. Siddhartha, the fuzzy seeds is invented in 1965. After that, lot of variations are there. One remarkable variation is intuitionistic fuzzy seed. The second one, intuition fuzzy graph, I have mentioned here. But after 1965, for the development of the fuzzy sets in 1983, Atanasov, he defined the intuitionistic fuzzy set. In fuzzy set, we are considering only one parameter, that one is called the degree of acceptance or degree of membership. But in 1983, Atanasov introduced another parameter, that one is called degree of membership, means degree of acceptance and degree of rejection. This statement is here. Somebody or accepting this statement and somebody rejecting or refuse that statement. So for this reason, there are two parameters associated to each element of a fuzzy intuitionistic fuzzy set. The corresponding fuzzy set is called intuitionistic fuzzy set. And the graph coming from that fuzzy set is known as intuitionistic fuzzy set. That means in intuitionistic fuzzy graph, there are two parameters are connected with each vertex and each edge. Okay. So these are known as denoted by mu. Mu is represents the degree of membership value, and mu is another parameter represents the degree of non-membership value. And there is a restriction: some of the membership values and non-membership values less than or equal to one. Okay. And in fuzzy graph, there is only one value. That one is called the degree of membership value denoted by dx. Third one is bipolar fuzzy. Pole means two poles are there. For this reason, it is called bipolar. That is one pole represents the positive membership value, and another parameter represents the negative membership. How much that particular statement is accepted or acceptable, and another parameter represents the dangerous issues of the another parameter of the same parameter. So two things are measured simultaneously. For a particular medicine, no? So medicine has some your medicine recovers some disease, and also some medicine has that medicine recover the disease, and on the same time that medicine has some side effects. So the side effects, the amount of side effects represent with the help of negative emotion. And positive emotion value represents the degree of goodness of that particular medicine. And another one is picture fuzzy graph. Picture fuzzy graph represents in that the or one parameter represents the degree of membership value. Another parameter represents the degree of non-acceptance. Some authors mention negative membership value, but practically it is non-accepting membership value. And third one is neutral membership. That means some people are saying that I have no idea for that particular statement. So that are the neutral things. Another type of fuzzy graphs also invented interval value fuzzy graph. That means each membership value are represented within an interval, not a particular point. Normally, the membership values is a number as written 0 and 1, but it has some limitation. So sometimes this particular value is extended to an interval. That means that interval value for this thing means the membership value is an interval, and that one is a subset of the unit interval 0, 1. Similarly, interval value inclusion fuzzy graphs are also available. Pythagorean fuzzy graphs are there, and it has two membership graphs. Basically, this is the extension of inclusionistic fuzzy graph. In inclusionistic fuzzy graph, the sum of membership and non-membership value lies between 0 and 1. And in Pythagorean fuzzy graphs, the sum of the square of membership values and non-membership values lies between 0 and 1. And similarly, a lot of other variants are available in literature. So this is an advantage to use, or sorry, the advantage to work on the fuzzy graphing. Based on the any type of fuzzy space, we can define a particular type of fuzzy graph. So there are another variation, your Neurosonic fuzzy graph, your J fuzzy graph. The J fuzzy set is invented recent years. Few days back, I have seen that the quantum fuzzy graph. So someone is here, she will deliver on quantum fuzzy graph or this type of modern fuzzy graph. So lot of variations are there. So anybody can start their research on this particular area fuzzy graph theory because there is a lot of scope to work on this particular area and it has lot of application to solve the real life problem. So this is a very beautiful diagram of a graph. So it is a complete graph. Complete graph means each vertex connected with other vertices, and it is K6. That is the entire graph contains 16 number of vertices, and all the vertices are connected with other vertices. So looks like a very good structure. And if any your physical quantities, structure of any physical quantity, this type that will be a very strong one. So Bayesian, the Bayesian is a hexagonal diagram. So Bayesian is a very strong, your physically strong. Okay, so strong fuzzy graph is and see that the complement of a fuzzy graph. So complement of a graph we already studied, but here the complement of fuzzy graph is little bit different. Little bit different means all the vertices of the original graph are the vertices of the complement graph. That means there is no differences between the vertices, both the graph, original graph as well as the complement graph. But there is a restriction on the edges. So see that what is the membership value of the edges in the complemented to a new graph? The membership value of an edge you equal to sigma u and sigma b. means minimum of sigma u and sigma v minus the membership value of the original. Okay. So this is the expression to find out the membership value of the edges in the complement. So as per this definition, if a vertex is present, sorry, if an edge is present in the original graph, that vertex is also, sorry, not also, the vertex, sorry, edge may or may not be present in the complement graph. But in the conventional graph theory, if an edge present in the original graph, that is never present in the complement graph. But in positive graph, and an edge, if it is present in the original graph, that or an edge may or may not be present in the complementary graph. So see that this is a given diagram. This is a very simple diagram with the membership value of edges and vertices are mentioned, the vertices and edges, and this is the complement. So see that there is no edge between A and D, but that edge is present in the your complement graph. And similarly, the other thing, these are the calculation. Sorry, this is the your complement graph, fully complement fuzzy graph with the different membership. So I will not explain it in details due to the lack of time. And there is another particular type of so another particular type of algebra. This is called the planar algebra. So what is new in this class here? Planar algebra. These are the application of planar algebra in the traffic light signaling. That concept we have considered or incorporated, and this paper is published in 2015. See that the left hand side is a very non-planar graph. This is the smallest non-planar graph. Because why it is non-planar? Because see that the two edges are crossed. No, these two edges are crossed in the inner and lower edges. The right hand figure, see that XY edge. No, XY edge is there. So XY is visible or not? Visible. XY is not. XY? XY is visible. Now somebody is saying that it is visible, somebody is not seeing the properly. As per my eyes, it is not visible. But edge is there. That edge is there, the color is yellow color edge, and that is another edge. That edge is not in the mark here. So the important thing is see that the XY is crossed with the other edge, but it is not visible. So this is actually leads to incorporate the fuzzy planar graph. Edges are clear, they have intersect at a particular point, but see that the importance of this intersection is very low because the appearance of the edge xy is very low. And so for this low edge means the membership value is low. And another edge is there, its membership value is high. If the membership value of an edge is very low, and if the membership value of another edge is high, then we can say that that particular load edge has a little bit importance to construct any road connection or any kind of connection. So this actually gives that means there is an edge, but depending on this your analogy uh, scenario, we have defined the degree of planarity of the person. Degree of planarity. That means in the fuzzy planar graph, every fuzzy graph is a planar. Every algebra is a planar graph, but we have calculated the degree of that particular algebra. If the definition is this one, and if the degree of your planarity, it should be like between 0 and 1, not before it is 0. So it is strictly greater than 0 and less than or equal to 1. If it is exactly equal to 1, then it is the great star. And if it is near to 0, that means it is highly fuzzy. And if it is close to 1, it is a almost or towards your fits the conventional. So this is a very important parameter developed by us, is myself and Shobham. And okay, we have calculated this is an application and details. So first is a book. That one is the first book published in 2000. This is the first book published in 2000 for the fuzzy graph. And these are the other papers. The third one is the IEEE convention, fuzzy planar published in IEEE convention on consider in 2015. And these are other papers related to my presentation. And this is an edited book, Modern Tapes in Fuzzy Graph, written by myself, Shobhan Samantka, and Varsar sir here. together published this book. This book published in 2020. So thank you, all of you. This is a picture of London. And if you have any question, then we can take one, two questions due to the shortage of time. Any question from students, scholar, or from the participant from online? Sure, sir. How should we calculate the membership values on the real fields? Or any relation or any. This is a very old question, well-known question. How we can calculate the membership value? So the answer is also readily available. So the membership values are calculated by decision makers. Now, question is, who is decision maker? The person who can take the decision. Okay. So there is another method is here. That one is statistical based method. We can create some sample. No, lot of sampling techniques are there. Our PG students remember the different type of sampling. So one sampling is the base sampling, stratified sampling. By using the stratified sampling, we can choose different sample, and it can you are asked their value. So the value of a proposition or any statement, you may take this proposition as per your perception. Okay. So by taking the samples, we can calculate. So if the sample size is 1,000, and a lot of people, say 500 people or 600 people, are support to your statement, and some other people are not supporting the statement. So by calculating the ratio, that means 600 by 1,000, that gives the membership value of the statement. So this is one better way to find out the degree of membership. But for different problems, I get results. There is no specific, and this is the one of the challenging issue to consider the membership. This is a very challenging issue. Every members of our department, our those who are working on this budget system, they know what is the difficulties of this. Any questions? Thank you, sir. One query from yes. Thank you, sir, for your nice presentation. One question is, in your hand slide, is there any fuzziness? All these things are so to see that the tree, this tree is little bit your clear, no? The last one, this tree is little bit clear. So we can assign a clearness. If we represent the degree of clearness by fuzzy number, so it is almost 0.9. And this tree, the leaves are covered by your eyes. Okay. So the clearness is or haziness is less than your 1. That means it may be you can assign 0.7 like that. This is more hazy. This portion is more hazy. These houses are too much hazy. So based on the degree of haziness, we can assign the membership. So I can say in terms of haziness or clearness, the entire picture is a positive. Thank you, sir. Any questions? Inquiries? One query. Not me. From the chair. Actually, I have mentioned there are different variants of Haji. But suppose we have a problem, and in that problem, which Haji variant will be most fitted, how that can be detected? So, based on the problem and based on your intention, what you want to solve. So, if you consider only the membership things without considering the other things, then fuzzy safety is better. Because only one parameter, it is very easy to solve and handle the entire problem. But if we want to consider the acceptance, degree of acceptance as well as degree of rejection, any statement, sorry, on say your not mathematical statement. Some statements are there that particular statement means some person accepting and some person rejecting. So if you want to include the rejecting portion also, then you can consider intuitionistic state because that state handles two things: acceptance, degree of acceptance, parallel of rejection also. You can also use the bipolar fuzzy sets if you try to incorporate or analyze the degree of acceptance and degree of negative or degree of not rejection, negative membership. Negative membership level, I mentioned that if the in a particular medicine, it has some positive things, positive issue, that means that particular medicine can recover from a particular disease, and sometimes it has a lot of side effects. So degree of side effects represents the negative membership value, and degree of the recovery of the disease is considered as a positive. So based on this kind of situation, you can consider different type of answers. Or nowadays, microscopic participation on here, you consider the truth values, false values, and the neutral values. The picture participate is there. This particular participate consider degree of acceptance, degree of non-acceptance, both are different and including the neutral values. That is the picture fuzzy and neutrosomic shapes. Both have three quantities. One is three quantities. But the conceptually they are different. Neutrosomic consider the truth value first one. The picture fuzzy consider acceptance and non-acceptance. All these things are different. So based on the problem and based on your intention to solve how much type of your how amount of investigation you will do, that depends on that one needs to consider or choose the this set.
Last query. Actually, handicap theory actually stand on the restriction. The membership value of age that will be less than equal to minimum of membership value of vertices. Actually, this restriction how has been developed. It will be greater than. It should be. I think
it should be greater than. It should be less than. If it is greater than, no. So then we have mentioned a type three of a red color. We have mentioned a fascicular with red color, type of fasciculars. So in that case, that was mentioned. Vertices are uncertain. Okay, but age membership value is certain. So see that age is there. Age is there, but names are uncertain. So how it was in reality, in real sense. Road is there, but there is no age place. Okay. In the graph theory, vertices should be there, and vertices connecting by age. So here, that particular type mentioned that the age is certain, but the vertices are uncertain. The vertices, there is no existence of the vertices. How there are, how is the possibility of existence of X? This is a big question. Mathematically, it is okay. But if we impose this condition, that type of non-realistic cases will disappear.
it's really not possible.
It's really not possible. But see that data then is not there, but that restriction not changes in different cases. Okay. And again, some theories which is already we have observed that if this condition is not imposed in the result, result will does not follow the rules of mathematically. Some authors have developed theories regarding the fuzzy graphs, but mathematically they are not correct. If we remove this restriction, if we consider this restriction, all the properties which are available in the of the fuzzy graphs are Shubham and other people, they have removed that restriction and imposed another condition. The condition should be clear.
Okay, thank you, sir, for your beautiful and nice explanations. I think from your explanations, participants will be much benefited. So, big clap for our